You are standing at the edge of a turnpike road somewhere in the English Midlands in the early 1820s, and the first thing you notice is the mud. It is not raining at this exact moment, but it has rained recently, and the road surface bears the consequences of that in the form of deep wheel ruts cut into the softened ground, pooled water sitting in the lower sections where the road's drainage has failed to clear it, and a general churned quality to the surface that any vehicle attempting to pass over it will have to contend with directly. A loaded coach moving along this road does not move quickly. It moves at the pace that the road's condition, the strength of the horses, and the skill of the driver collectively permit, and on a day like this one, that pace is considerably slower than it would be on a dry road in good repair, which is itself slower than anyone making this journey today would consider acceptable. Distance in this world is not simply a number of miles. This is the central fact you need to understand before anything else in this study makes sense. A journey from Manchester to London in this period is a serious undertaking, planned in advance, requiring overnight stops, fresh horses at coaching inns along the route, and a genuine acceptance on the part of the traveller that several days of their life will be consumed by the simple act of moving from one city to the other. The roads connecting Britain's major towns and cities, even the better maintained turnpike roads operated by private trusts that collect tolls in exchange for keeping the surface in reasonable condition, are subject to weather, to wear, to the simple physical limitations of horse-drawn transport carrying weight over long distances at sustained speed. A horse can only travel so far before it requires rest, water, and replacement with a fresh animal if the journey is to continue at any reasonable pace. The coaching inns that punctuate the major routes between English cities exist specifically to service this requirement, providing the change of horses and the brief rest for passengers that long-distance road travel in this period absolutely depends upon. Canals offer an alternative for the movement of heavy goods, and they have transformed the economics of bulk transport considerably since their major expansion in the previous decades. A canal boat can move a quantity of coal or raw material that would require dozens of cartloads to shift by road, and it can do so more cheaply per ton, even though it moves more slowly. But canals are themselves slow, subject to lock delays, to weather affecting water levels, to the simple limitation that a horse walking along a towpath pulling a loaded barge through water does not move quickly, even under good conditions. Each town along whatever route you might travel keeps its own time, and this fact, which will become enormously significant later in this examination, currently causes almost nobody any practical difficulty whatsoever. The church clock in the town you are passing through is set, as church clocks throughout England have been set for centuries, according to local solar observation. The moment the sun reaches its highest point in the sky on a given day is local noon, and the town's clocks are calibrated to that local astronomical reality. A town 100 miles to the east, due to the simple geometry of the Earth's rotation, experiences its own solar noon several minutes earlier than the town you are currently standing in. This difference is real, measurable, and at this moment in history almost entirely without consequence, because nobody is attempting to coordinate precise simultaneous movement between these two towns. A coach traveling between them takes the better part of a day, regardless of the few minutes of solar time difference involved, and nobody's safety depends on the precise minute at which anything happens in either location. This is the old rhythm of distance and time in industrial Britain before the railway begins to change it. Local, slow, uneven in its pace from one stretch of road to the next, from one season to the next, from one weather event to the next, limited fundamentally by the physical effort that a horse or a team of horses can sustain, and by the condition of whatever surface that effort is being expended upon. If you haven't already, subscribe to the Sleep-Inducing Historical Archive. Comment below and let us know which of our studies bores you to sleep the most. Settle in. The iron is already being laid in certain parts of the country, and the world this section has described is about to begin changing more quickly than anyone standing in this muddy road would expect. By the late 1820s and into the 1830s, a different kind of activity has begun appearing across stretches of the English landscape that connect the major coal fields, the factory towns, the ports, and the largest cities to one another. Surveying teams move across the countryside ahead of any actual construction, carrying instruments that measure gradient and distance with a precision that the road builders of the previous generation rarely required, because the requirements of a railway line are considerably less forgiving of gradient than the requirements of a road travelled by horses. A horse can climb a slope that would be entirely unworkable for a steam locomotive hauling a loaded train, and so the surveyors plotting a railway route through hilly or uneven terrain are searching for paths that minimize gradient, even when this means the route must curve, tunnel, or be elevated above the natural ground level, rather than simply following the most direct line between 2 points. Where the survey identifies a hill that cannot be reasonably avoided, the construction gangs cut directly through it. A railway cutting through a hillside in this period is dug almost entirely by manual labour, men with picks and shovels and barrows, working in organised gangs under contractors who are themselves under enormous pressure from the railway companies financing the construction to complete the work within budgets and timelines that often prove considerably more difficult to achieve than the original estimates suggested. Where a valley or a river interrupts the planned route, the gangs build embankments to raise the track level or excavate further to lower it, and where neither approach is sufficient, they build bridges and viaducts, substantial brick and masonry structures designed to carry the weight of a loaded train across a span that the natural terrain cannot otherwise accommodate. These structures, once completed, become permanent features of the landscapes and townscapes they pass through in a way that earlier transport infrastructure rarely achieved at the same scale. A brick viaduct carrying a railway line above a street in an industrial town does not disappear when the railway company's immediate construction needs are satisfied. It remains, indefinitely, as a permanent alteration to the physical geography of that street. The street itself now running beneath an elevated structure that did not exist a few years earlier. Its scale and its permanence a statement about the kind of investment and the kind of long-term commitment that railway construction represents compared to the more incremental and more easily modified infrastructure of roads and canals. The routes chosen for these lines frequently pass directly through or immediately adjacent to the industrial districts this entire series has been examining, behind the warehouses, past the mills, alongside the foundries, in close proximity to the rows of worker housing that study number 5 described in detail. This is not coincidental. The railway exists in its earliest and most economically significant applications to serve exactly these industrial functions. Moving coal from the coal fields to the factories and cities that burn it, moving raw cotton to the mills that process it, moving finished goods from the manufacturing centers to the ports that export them. The railway's geography follows the geography of industrial production, threading itself through the same districts that the mills and the foundries and the worker housing already occupy, adding a new layer of permanent infrastructure to landscapes that the previous decades of industrial expansion had already transformed substantially. What is being built here is not simply a faster road. A railway line is a fundamentally different kind of infrastructure from anything that preceded it. A permanent corridor engineered to a precision and a consistency that road building had never required, requiring a coordination of land acquisition, capital investment, engineering expertise, and organized labor on a scale that exceeds almost anything the country had previously attempted outside of its largest civil engineering projects. The country is not being made physically smaller by this construction. The actual distances between Manchester and London, between Birmingham and Liverpool, remain exactly what they have always been. But the relationship between those physical distances and the practical experience of crossing them is about to change in a way that the surveyors and the navvies currently cutting through the English countryside can only partially anticipate. A train moving along a completed railway line represents the visible end product of a labour system considerably more extensive and more specialised than the moving train itself suggests. The navvies who built the line, the term applied broadly to the manual labourers who performed the cutting, the embanking, the tunnelling and the general earth-moving work that railway construction required in enormous quantity, represent only the construction phase of this labour system, substantial and demanding as that phase undoubtedly was. Once a line is operational, an entirely different category of specialised labour becomes necessary to keep it functioning safely and reliably, and this labour is organised according to a discipline and a division of responsibility that has no direct precedent in the factory systems this phase has already examined, even though it shares certain underlying principles with them. Track maintenance workers move along the completed line in organized gangs, inspecting and adjusting the alignment of the rails, checking the condition of the sleepers that support them, identifying and addressing the gradual wear, and settling that any heavily used piece of mechanical infrastructure inevitably experiences over time. Their work is less visible than the original construction, but no less essential. A rail that has shifted out of proper alignment, even by a small margin, represents a genuine safety hazard to anything moving over it at speed, and the consequences of an undetected fault in the track are considerably more severe than the consequences of an undetected fault in a stationary piece of factory machinery. Signalmen occupy a role that has no real precedent in earlier transport systems, stationed at intervals along the line, often in small dedicated signal boxes positioned to provide clear sight lines along the track in both directions. The signalman's responsibility is to manage the safe passage of trains through his particular section of the line, ensuring that two trains do not attempt to occupy the same stretch of track simultaneously, communicating the status of the line ahead to approaching trains through a system of mechanical signals that the railway companies developed and refined considerably over these decades as the consequences of inadequate signalling became apparent through painful experience. Engine crews, the driver and the fireman who together operate the locomotive, perform a continuous and demanding labour throughout every journey, the fireman maintaining the boiler's fire and water level to keep the engine producing the steam pressure the journey requires, the driver managing the engine's speed and responding to the signals and the track conditions ahead. This work bears some resemblance to the engine room labour described in study number 4's pumping stations, but it carries an additional dimension of responsibility, since the engine crew's decisions directly affect the safety of everyone aboard the train they are operating, in a way that a stationary pumping engine's operators did not need to consider in quite the same immediate sense. Clerks and station staff maintain the administrative infrastructure that allows the railway company to track the movement of its trains, its goods, and its passengers across a network that may extend across a substantial portion of the country. Records of departure times, arrival times, freight manifests, passenger counts. All of this generates a volume of paperwork considerably exceeding what any previous transport system required. because the railway's value depends substantially on its reliability and its predictability, and reliability and predictability require record-keeping at a level of detail that casual road transport never demanded. What unites all of these specialized roles is a shared understanding that the railway cannot operate casually in the way that road transport could, to a considerable degree, tolerate minor inconsistencies and delays without serious consequence. A loose rail, a late train, a blocked line, a switch that has not been properly maintained. Any of these failures has the capacity to disrupt not merely the immediate journey affected, but everything scheduled to follow it along the same section of track, in a cascading consequence that road transport's more flexible and more individually negotiated movement patterns rarely produced at the same scale. The railway, in this sense, creates a form of industrial discipline that extends considerably beyond the factory floor that this phase's earlier episodes examined. The factory worker's discipline is organized around a single building, a single set of machinery, and a single overseer's field of vision. The railway worker's discipline is organized around a moving system that extends across the entire length of the line and depends on coordination between workers who may never see each other directly, but whose individual actions must nonetheless align precisely with what every other worker along the same system is doing at the same moment. People no longer work only beside machines in the way the mill operatives of Studies 1 and 2 worked beside their frames and looms. They work to keep an entire moving system, machines, cargo, passengers and schedules together, functioning across distances that no single worker can directly observe in their entirety. The railway station, as it develops through these decades into the substantial and increasingly elaborate structures that come to define the major cities' rail terminals, represents something genuinely new in the experience of moving through industrial Britain. The platform surfaces, within a relatively short period of operation, darken with the same soot deposit that this entire phase has documented accumulating on every exposed surface in industrial England. The locomotives themselves burning coal continuously to generate the steam pressure their operation requires, deposit smoke and particulate matter onto the station structures with a directness and a concentration that even the general atmospheric haze described in study number 3 does not quite match. A station roof in the larger termini develops a blackened underside within a few years of operation. The accumulated deposit of thousands of departing and arriving locomotives venting their exhaust into the enclosed or partially enclosed space above the platforms. Within this increasingly soot-darkened environment, an entirely new kind of crowd assembles, drawn from a range of the population that previous forms of transport rarely brought together in the same space at the same time. Factory workers traveling to new employment in a different town, merchants moving between cities to conduct business that previously would have required a multi-day journey, now condensed into a single day's travel each direction. Soldiers being moved between garrisons with a speed and coordination that earlier military logistics could not have achieved. Clerks, travelers of more modest means, seeking opportunities at a distance from their home district. Laborers moving in search of work wherever the expanding industrial economy currently required additional hands. The station does not function as a village meeting place might function, with its loose and informal social mixing among people who broadly know each other and broadly share a similar daily rhythm. It functions instead as a controlled threshold, a space deliberately organized to sort the people passing through it according to a set of categories that the railway company's operational requirements have established. Ticket windows separate those who have purchased passage from those who have not. Waiting rooms in many stations are explicitly divided by class of travel, reflecting the tiered pricing structure that railway companies adopted from very early in their operation, offering first, second, and sometimes third-class accommodation at correspondingly different fares and correspondingly different levels of comfort. Porters move through this crowd, managing the luggage that accompanies long-distance travel, their labor an essential but largely unremarked component of the station's overall function, ensuring that passengers and their belongings are matched correctly to the appropriate train and the appropriate platform. Whistles signal departures and warn of approaching trains, a new auditory feature of urban life that did not exist in this form before the railway's arrival, piercing and specific in a way distinct from the general industrial noise this phase has documented elsewhere. The visual order of the station reinforces this sorting function at every point. Signs direct passengers toward the correct platform for their destination. Timetables, posted prominently and updated as schedules change, provide the information that passengers require to plan their movement through the station's controlled sequence of waiting, boarding, and departure. Clocks, and this detail will become considerably more significant in the sections that follow, are mounted prominently throughout the station, their accuracy and their consistency essential to the entire system's reliable function. Numbered platforms organize the physical space according to the network of destinations the station serves, and railway staff, positioned at key points throughout the station, direct movement and answer questions in a role that did not exist in this specific form before the railway required it. What this entire arrangement achieves for the traveling public experiencing it for the first time in these decades is a genuinely new relationship with distance. A person can leave one industrial city in the early morning and arrive a considerable distance away before the day has ended. A journey that the coach travel described in Section 1 would have required several days to accomplish, now compressed into a matter of hours. Distance has not changed in any physical sense. The miles between Manchester and London remain exactly what they were, but the practical authority that those miles exercise over a traveller's life, the days of planning, the overnight stops, the physical exhaustion of the horses and the passengers alike, has begun, for the first time in British history, to genuinely diminish. There is a complication embedded within the railway's expanding network that the system's early planners did not immediately anticipate with the seriousness it would eventually demand, and it concerns a fact about time that had never previously mattered very much to anyone. Every town in England, as established in Section 1, keeps its own local time, calculated according to the actual solar observation appropriate to that town's specific longitude. This produces real and measurable differences between the clock time in different parts of the country. A clock in Bristol, calibrated to Bristol's own local solar noon, will show a slightly different time than a clock in London, calibrated to London's local solar noon, the difference amounting to approximately 10 minutes given the distance and the geometry involved. A clock in Liverpool differs from a clock in Birmingham by a smaller but still measurable margin. None of this discrepancy has historically mattered, because nothing about pre-railway transport required precise synchronization between distant locations. A coach travelling between Bristol and London takes the better part of a day in any case, and the 10-minute difference in local solar time between the two cities is utterly insignificant against that scale of journey duration. The railway changes this calculation entirely, and it does so for reasons that become apparent as soon as multiple trains begin operating on shared sections of track according to published schedules. A single railway line connecting two towns, with trains departing and arriving according to a printed timetable, requires that timetable to be understood identically by everyone responsible for its execution. The station staff dispatching trains, the signalman managing the line's safe operation, the engine crews adjusting their speed to maintain the schedule, the passengers planning their arrival at the station in time to catch their intended departure. If the timetable specifies a departure at a particular hour and the station clock in the originating town shows a different time than the station clock in the destination town, because each is calibrated to its own local solar observation, The practical result is a genuine and dangerous ambiguity about exactly when events along the line are actually occurring relative to each other. This ambiguity matters most acutely on lines where trains travelling in opposite directions must pass each other safely, or where a single track is shared by trains operating on a schedule designed to keep them safely separated by precise time intervals rather than by the more flexible spacing that road traffic could tolerate. A signalman managing a junction needs to know, with confidence, exactly when an approaching train is scheduled to arrive, and that confidence depends on the signalman's clock and the train's own operating schedule, referring to the same understanding of what time it currently is. When the originating station's clock and the signalman's clock are calibrated to different local solar times, even by a margin as small as 10 or 15 minutes, the safety margins that the railway's operation depends upon begin to erode in ways that the system's early growth made increasingly difficult to ignore. The railway companies, confronting this problem directly as their networks expanded and as the consequences of timing discrepancies became apparent through near misses and, in some unfortunate instances, actual collisions, arrived at a conclusion that the system's logic made essentially unavoidable. A railway network spanning multiple towns and multiple local time zones cannot operate safely if it continues to defer to each town's individually calculated local time. It requires a single, shared, dependable standard of time that every station, every signal box, and every published timetable across the network refers to identically, regardless of what the sun happens to be doing directly overhead in any particular town at any particular moment. The sun, in other words, was about to lose its long-standing authority over what time it actually was in any given English town. And the railway was the institution that would force this change, not through any deliberate philosophical campaign against local custom, but through the simple practical necessity of keeping its trains from colliding with each other. Through the 1840s, the railway companies operating across Britain's expanding network increasingly adopt a single standard of time for their operations, and the standard they settle upon is London time, the local solar time of the capital, chosen not for any particular symbolic reason beyond London's status as the country's largest city and the location of the Royal Observatory at Greenwich, whose astronomical observations provided the most precise and most authoritative timekeeping available in the country. This adoption proceeds gradually and pragmatically, rather than through any single decisive moment of national reform. Individual railway companies, recognizing the safety risks that local time discrepancies pose to their operations, begin instructing their stations to set clocks according to London time rather than according to each station's own local solar calculation. Telegraph lines, which the railway companies had begun installing alongside their tracks for operational signalling purposes, prove unexpectedly useful for this additional function, carrying an accurate time signal from London out along the network, allowing distant stations to set and verify their clocks against the same authoritative source rather than relying on local astronomical observation that might drift slightly out of calibration over time. The printed timetables that passengers consult to plan their journeys are increasingly produced according to this common railway time standard, which means that a passenger checking a departure time in a station several hours' journey from London is now consulting a schedule calculated according to London's clock rather than according to the local solar time of the town they are actually standing in. This transition does not happen without friction, and the friction is worth understanding honestly rather than glossing over for the sake of narrative tidiness. Some towns, accustomed to their own local time and somewhat resistant to the idea that a distant railway company's operational convenience should override centuries of local astronomical tradition, continue maintaining their traditional town clocks alongside the new railway clocks for a period, producing the genuinely curious situation of certain English towns operating for some years under two simultaneously displayed times. The town's own clock showing local solar time, the station clock showing railway time. The difference between them, a visible and occasionally confusing few minutes, that residents simply learned to account for depending on which activity they were engaged in. The practical message embedded in this transition, however gradual and however unevenly it was initially received, is straightforward and increasingly difficult to resist as the railway's importance to daily commercial and personal life continued expanding. The sun may continue rising and setting according to its own local schedule in any given town, and the church clock may continue marking that local solar reality for whatever traditional or ceremonial purposes the town wishes to preserve. But the train, when it departs according to the railway's clock, and a passenger whose understanding of time differs from the railway's understanding of time will simply miss their train, regardless of how confident they feel in the accuracy of their own town's traditional timekeeping. What is happening here beneath the surface of what might appear to be a relatively minor administrative convenience is a genuine reorganization of how an entire country understands and experiences time itself. For the whole of England's history up to this point, time has been a fundamentally local phenomenon, calculated independently by each community according to its own position beneath the sun. The railway, through nothing more dramatic than the practical requirements of running trains safely on a shared schedule, has begun replacing that fundamentally local understanding with a single shared, nationally consistent standard, not yet formalized into law, not yet universally adopted outside of railway operations specifically, but increasingly the practical reality that anyone wishing to travel by train, or to coordinate any activity with someone who does, must learn to operate within. The printed timetable, considered simply as an object, is unremarkable. A sheet or a small booklet of paper listing departure times, arrival times, and the stations served along a particular route, distributed to stations and sold to the travelling public for the modest cost of acquiring the information it contains. Considered as an instrument of authority within industrial Britain's rapidly developing systems of coordinated movement, the timetable represents something considerably more significant than its physical modesty suggests. It tells the passenger when they must arrive at the station if they wish to catch their intended train, and this instruction carries a weight and precision that earlier forms of travel planning rarely required. A traveller arranging passage on a coach in the earlier decades of this episode could negotiate directly with the coaching company, could often arrange for some flexibility in departure time if circumstances required it, could rely on a degree of personal accommodation that the relationship between an individual traveller and a relatively small coaching operation made practically available. The railway timetable offers no equivalent flexibility. The train departs at the time printed on the schedule, regardless of any individual passenger's personal circumstances, because the train's departure is coordinated with the operation of every other train sharing the same network, and a delay accommodated for one passenger's convenience would propagate forward through the entire system in ways that the railway company's operational logic cannot tolerate. It tells the worker when to report for duty in railway employment specifically, but increasingly in other forms of industrial employment that have begun organizing their own schedules in reference to railway arrivals and departures. A factory receiving its raw materials by rail must coordinate its own receiving operations with the train schedule that delivers those materials, and a worker employed in that receiving operation finds their own working hours increasingly shaped by a timetable they have no personal control over and very limited ability to negotiate. It tells freight when to move, coordinating the loading and dispatch of goods according to a schedule that the shipping merchant, the railway company, and the receiving customer at the other end of the journey must all observe in common, replacing the more individually negotiated and more flexible arrangements that road and canal transport had previously allowed. It tells connecting trains when to wait for a delayed arrival and when to depart, regardless of whether expected connecting passengers have managed to make their transfer in time, a decision that railway companies formalized into explicit policy precisely because the alternative, indefinite flexibility in connection times, would have made the entire network's schedule meaningless within a very short period of operation. The timetable, in this sense, does not care whether a person is tired, delayed by circumstances entirely outside their control, wealthy enough to expect some accommodation, poor enough to have no recourse if the schedule fails to serve them, or simply accustomed to a more personal and more flexible pace of life, that the railway's standardized schedule has no mechanism to acknowledge. The train departs at the printed time. A passenger who misses it has missed it, and the system, having no individual relationship with that specific passenger comparable to what a coaching company might have maintained with its regular customers, simply continues its operation without him, the next train departing at its own scheduled time, regardless of who failed to catch the previous one. This represents, in miniature, the same broader transformation that this entire Phase 4 series has been documenting across different systems and different settings. The replacement of individually negotiated, locally variable arrangements with standardized, repeatable schedules that serve the requirements of the larger coordinated system rather than the particular circumstances of any individual person operating within it. The Mills bell, examined in study number 1, replaced the flexible pacing of cottage labour with a fixed schedule determined by the requirements of the machinery. The railway timetable performs an equivalent replacement at a national rather than a building-specific scale, organising not just a single factory's working day but an entire country's experience of travel, commerce and increasingly expectation itself, around a standard that does not bend to accommodate the individual circumstances of any single person it governs. While the passenger experience of railway travel represents the most visible and most immediately personal transformation this episode has documented, the movement of freight by rail produces consequences for British industry that prove, in the longer run, at least equally significant. Coal, which study number 3's examination of industrial pollution established as the fundamental fuel underlying virtually every aspect of British industrial production, had previously depended on canal transport or road haulage to move from the coal fields where it was extracted to the factories, foundries and urban households that burned it in such enormous quantity. Both of these existing transport methods, while functional, imposed real limitations on the speed and the reliability with which coal could reach its destination. Canal transport subject to the lock delays and seasonal water level fluctuations already discussed. Road haulage subject to the same weather and surface condition limitations that constrained all road transport in this period. Railways, once established along routes connecting coalfields to major industrial centres, allow coal to move with a speed and a schedule reliability that neither canal nor road transport could previously match. A factory's coal supply, increasingly delivered by rail according to a regular and dependable schedule, allows for more confident production planning, reducing the risk of the kind of supply interruption that an unreliable transport system might otherwise impose on operations that depend on continuous fuel availability to keep their furnaces and engines running. Raw cotton, arriving at the port cities from overseas and requiring distribution inland to the mills of Lancashire that studies 1, 2 and 6 have all examined in different contexts, similarly benefits from the improved reliability and speed that rail transport provides over the previous combination of road and canal movement. A mill's production schedule, dependent on a continuous and predictable supply of raw material, operates more efficiently when that supply chain is mediated by a transport system capable of meeting published schedules with reasonable consistency rather than remaining subject to the variable and sometimes substantial delays that road and canal transport could impose. Finished goods, moving in the opposite direction from the manufacturing centres toward the ports for export or toward domestic markets for sale, benefit from the same improvements in speed and reliability, allowing manufacturers to meet delivery commitments with greater confidence and allowing the broader commercial system connecting producers to markets to operate according to tighter and more predictable schedules than the previous transport infrastructure had permitted. The relationship that develops between the railway system and the broader industrial economy this entire phase has been documenting is genuinely symbiotic rather than simply additive. The railways depend on industrial production for much of their own freight traffic and for the iron, the coal and the manufactured components that railway construction and operation themselves require in substantial quantity. Industrial production, in turn, increasingly depends on the railway network for the reliable movement of raw materials, fuel, and finished goods that its continued operation and expansion requires. The two systems, factory production and railway transport, function increasingly like two gears locked together, each system's expansion driving and depending upon the other's continued growth in a relationship that neither system could have achieved at the same scale operating independently. The human experience of this transformation, considered honestly and without excessive sentiment in either direction, involves genuine gains alongside genuine new forms of pressure that the previous slower pace of British life had not generated in quite the same way. Families separated by distances that would previously have made regular visiting impractical can now travel between each other with a speed that the coach travel of Section 1 simply could not provide. A daughter who has moved to a different city for work or marriage now able to visit her family of origin within a single day's travel rather than the multi-day undertaking that the same journey would have represented a generation earlier. Workers seeking employment can consider opportunities at a distance from their home district that the previous limitations of travel would have made impractical to pursue, expanding the effective labour market available to both workers seeking employment and employers seeking workers beyond what local geography had previously constrained it to. Newspapers and mail move between cities with a speed that transforms the practical experience of staying informed about distant events and conducting business with distant correspondents. A businessman in Manchester can receive information from London, respond to it, and have that response received and acted upon within a time frame that the previous generation's communication infrastructure could not have approached, accelerating the pace at which commercial decisions can be made and at which their consequences can be felt across distances that previously imposed substantial natural delay on any such exchange. This new connection, however, arrives accompanied by a new and less comfortable form of pressure that the previous slower pace of British commercial and personal life had not generated with the same intensity. Expectations rise, in direct relationship to the railway's demonstrated capacity to move people, goods, and information faster than the previous infrastructure allowed. A delivery that might previously have been excused for arriving several days later than originally hoped, given the acknowledged unreliability of road and canal transport, now faces a different standard, because the railway has demonstrated that faster and more reliable delivery is achievable, and the absence of that faster and more reliable delivery increasingly reads as failure rather than as the ordinary and forgivable friction of distance that it would previously have represented. A delayed worker, a missed connection, a late payment, a failed delivery, each of these now carries consequences that extend further and arrive faster than the previous, slower system would have generated because the entire commercial and personal infrastructure surrounding these transactions has recalibrated its expectations to the railway's new standard of speed and reliability, leaving considerably less tolerance for the kind of delay that the old infrastructure simply assumed as a normal cost of operating across any meaningful distance. The railway, in this sense, does not merely save time in any simple or uncomplicated way. It makes time itself more valuable, in the specific sense that the increased speed of movement raises the cost in commercial and personal terms of any failure to move at the new expected pace. It makes time more visible through the printed timetables and the station clocks and the railway time standard that this episode has documented, embedding a previously informal and locally variable concept into a precise and publicly displayed system that everyone interacting with the railway network must now consciously attend to. And it makes time, in a real and consequential sense, considerably less forgiving than the old system of local variable weather-dependent travel had ever required it to be. Return at the close of this study to the station clock that Section 4 first introduced, mounted prominently above the platform, its hands marking the railway time that has, across the course of this episode's decades, increasingly displaced the local solar time that every English town had previously maintained as its own independent and unquestioned standard. Beneath this clock, in any major station during the busier hours of the day, thousands of people move through their own individual journeys, arriving, departing, waiting, connecting between services, each of them governed in this moment by the same shared hour that the clock above them displays, regardless of where they have traveled from or where they are traveling to, regardless of what their own town's church clock might currently be showing several miles or several counties away. This is the visual anchor this entire episode has been building toward, and it is worth sitting with for a moment before the episode closes. The old world that Section 1 described, organized around local daylight, local roads, and the physical limitations that horse-drawn transport and weather-dependent travel imposed on any journey of meaningful length, has not disappeared entirely by the period this episode's later sections describe. Local custom persists in many forms. The church clock in many towns continues marking its traditional local time for whatever purposes the community still finds that distinction useful. The sun continues rising and setting according to its own unchanging schedule, indifferent to whatever standard of time the railway companies have adopted for their operational convenience. But the new industrial world that this episode has documented emerging alongside and gradually displacing the old one is organized around a genuinely different set of governing principles. Rails that connect distant points with a directness and a permanence that roads never quite achieved. Timetables that coordinate movement according to a precision that local and individually negotiated travel arrangements never required. Clocks that increasingly defer to a single shared national standard rather than maintaining their independent local authority, and signals that manage the safe movement of trains across distances and at speeds that earlier transport systems never needed to coordinate with comparable exactness. The railway, considered across the full span of transformations this episode has traced, does not simply connect British cities in the narrow sense of providing a faster route between two fixed points. It teaches industrial Britain gradually and through nothing more dramatic than the accumulated practical requirements of running trains safely and reliably across an expanding national network to move together, to share a single understanding of time, to coordinate individual movement with a national schedule rather than purely local custom, to accept that distance while never actually shrinking in any physical sense, has lost a meaningful portion of the authority it once held over how British life was organized, planned, and lived. The clock above the platform continues its steady progression through the hour, indifferent to the individual stories of everyone currently moving beneath it, simply marking the shared time that the entire system now depends upon to function. The trains will continue departing according to its authority long after tonight's travellers have reached their various destinations. The platform has emptied and the last train of the evening has pulled away into the dark beyond the station's lamps. You remain a moment beneath the clock, its hands marking the same hour they will mark again tomorrow, indifferent to whatever the sun is currently doing over whichever distant town a traveller might have come from. The rails outside continue into the darkness in both directions, carrying the country's shared hour wherever they lead. These are the systems that taught an entire nation to move by the same clock, not by force, but by the quiet and continuous logic of keeping the trains from colliding with each other. If you'd like to return, the archive is open.